Bismillahirrahmanirrahim. Assalamu alaikum. My name is Adil Abbas and today I'm here to present about the summary and SWOT analysis of a research paper titled as The Effect of Spectrophotometer Geometry on the Maillard Color for Textile Samples with Different Textures. Here are the contents of presentation. In first part of introduction and summary, we will see the objectives of research, theoretical and statistical terms involved in the research and experimentation, while in results and discussion, we will see the obtained results of research, reasoning behind those results, and discussions of results, while in SWOT analysis and conclusion part, we will do a complete SWOT analysis of the current research and we will see the some internal and external factors which are involved in SWOT analysis, and at the end we will conclude our presentation. Here are the objectives of research. The first one is to observe the overall effect of spectrophotometer geometry's reference on color measurement of same samples, to observe the L, A and B coordinate values difference of same colors measured through two spectrophotometers of D by 8 and 45 by 0 geometries, to observe and calculate the L, A and B coordinate values difference of same sample manufactured via same color yarns but different fabric textures, to measure the color by 10-degree observed by human eye using common grayscale method and compute its relationship with the colors measured via spectroscopy, and to statistically calculate the effect of textures and color center of samples on different values of colors measured through spectrophotometers of two different geometries. Firstly, we will discuss the theoretical and statistical terms involved in the research paper. And the first term is spectrophotometer. The spectrophotometer is a device consisting of a light source, monochromator, and a photodetector for color measurement. The working principle of the spectrophotometer is shown in the figure, that there is a light source, a lens, and a monochromator which converts a light into a specific wavelength, and then this wavelength is thrown on the sample, and the photocell shows the results in digital values. These digital values are generally L, A and B values or XYZ values, or either these can be the LCH values. The second term is the geometry of spectrophotometer. Basically, the spectrophotometer's geometry is defined as an angular relationship between the illumination source and observation with respect to the sample. The author in the research used two types of spectrophotometer geometries for comparison. The first one is diffuse by 8-degree geometry, while the second one was 45 by 0 geometry. The figure shows diffuse by 8-degree geometry, that the source of illumination is diffused while the detector, which is the observation point of spectrophotometer, is present at 8 degree with respect to the sample. And the third one term is L, A and B values, which is frequently used in the research. Actually, L, A and B values are the color coordinates which are obtained as a result from the spectrophotometer. L, A and B values represent the following matter, that the positive A value will show that color is moving toward the red, while the negative value will show that color is moving toward the green hue. Similarly, the positive B value will show the yellow color and negative B value will show the bluish color, while L value represents the whiteness or blackness of the sample. Here the figure shows 3D relationship between L, A and B values, that as L value is increasing, the sample is becoming whiter, and decreasing, it is becoming blackish. Similar is the relationship between A positive and A negative, B positive and B negative values. The fourth term is confidence level in statistical analysis. The confidence level in statistical analysis defined that parameters should be this percentage true. For example, in the current research paper, author used a 0.95% confidence level. This means that the results analyzed through Minitab are 95% true, and there are only 5% errors and omissions expected. While the fifth term used was the p-values, it was also used in statistical analysis. P-value is actually defined by the confidence level. If confidence level is 0.95, then the p-value will be 0.05 as a standard, and all the input parameters are compared with that p-values, and the parameter which is showing p-value greater than 0.05 will not have any significant effect on output factor. For example, in the research paper, texture showed p-value greater than 0.05, so textures were neglected while comparing the geometries of both spectrophotometers. Here are the materials and methods. Polyester yarn of 160 denier was used in 9 colors of grey, red, orange, brown, yellow, green, blue, purple and pink, while knitting fabrication technique was used to create different textures on the surface of fabrics. And here is the experimentation of research. The 63 samples were manufactured with 7 different textures and 9 different colors, while the 18 people were selected for visual examination of color variation with respect to texture. But these 18 people were firstly passed through the Ishihara test of color blindness in order to check these are color blind or not. The standard illuminant of day 65 was used for sample illumination in spectrophotometer while also in the visual assessment of samples. Firstly, the samples were observed under the diffuse by 8-degree geometry in Greta Macbeth Color Eyes 7000 A spectrophotometer with specular component included, and the results were obtained in the form of L, A and B color coordinate values. After diffuse by 8-degree geometry, the 45 by 0-degree geometry was used in Hunter Lab Miniscan Easy with the same standard illuminant of day 65, and all other laboratory conditions were kept same. The difference between the L, C and H values was also obtained by calculating the delta C star and delta H star values by the specific formula defined by CIADE 2000. In the formula, the SC is representing the scattering coefficient of sample, while Kc is representing the absorption coefficient of sample, which is also obtained in the results of spectrophotometer. Here are the results of research. The firstly results shows that the different geometries of spectrophotometers shows that there are different L, A and B values for samples, and here in the table it can be clearly seen for a gray sample that L value for first texture of gray is 59.82 in 45 by 0 geometry, while in diffuse by 8 geometry the same sample showed the L value of 60.23. So it means that L, A and B values are affected by the spectrophotometer geometry. And the second one point showed that overall L values obtained by diffuse by 8-degree geometry were greater than the 45 by 0-degree geometry. This can be due to that diffuse by 8-degree geometry used the specular component of light, while the specular component was excluded in the case of 45 by 0-degree geometry. After the comparison of results, another test was performed in the Minitab statistical software, and the relationship between the all involved input factors, which were geometry difference, textures, and illuminants, were obtained with the output factor, which were the L, A, and B values of samples. The first statistical analysis showed that the p-value for chroma is 0.045, which shows that the due to change of geometry of spectrophotometer, the chroma of color is greatly affected, while the p-value obtained for hue was between 0.08 for some samples to the 0.0. So it means that the some sample affected their hue due to spectrophotometer geometry, while the hue for some samples remained constant by changing the geometries of spectrophotometer. So it can be said that the hue values vary from a color to color by changing the spectrophotometer geometry. The comparison of results of both spectrophotometers showed that their overall delta E value of colors changed from 0.4 to 4.8 units by changing the textures of samples. So overall textures effect was negligible by changing the geometries of both spectrophotometer. It remained constant. while the color center of sample was greatly affected by the measurement of color by different geometries rather than the textures and colors. As the visual assessment of color was also done by selecting the 18 people, and here in the figures D by 8 spectrophotometer geometry and 45 by 0 spectrophotometer geometry measured color values are plotted with the visual assessed values of colors, and the graphs clearly show that the visually measured values are totally different from the values measured through the spectrophotometer, because the graph is so much scattered and no linear relationship can be made, while the red line shows the line of regression equation which was calculated in the statistical analysis in the Minitab statistical software. Here is the SWOT analysis, termed as strengths, weaknesses, opportunities, and threats analysis of any project or research. And this analysis shows some internal factors and some external factors related to the research. Internal factors are considered as strengths and weaknesses of the research, while the external factors are the opportunities and threats related to the research. So let's start the SWOT analysis of our selected research paper. And the diagram shows the strengths, weakness, opportunities, and threats related to the research. The strength portion shows that the geometry choosing involving surface textures, statistical analysis, visual assessment, and using wide range of colors are the strengths of this research paper, while the weaknesses are keeping yarn count constant, no laboratory conditions described, chroma and hue values were not described, gloss trap condition of both spectrophotometers was not same, and no change of standard illuminant, while the opportunities which are derived from the research are a gateway of using different geometries of spectrophotometer and creating fabrics with different L, A and B values while using the yarns of same color, and promoting the use of statistical analysis. The threats of the research are neglection of yarn count effect, neglection of textures effect on the spectrophotometer geometries, and wrong color comparison due to different conditions of spectrophotometers. Uh, so let us discuss these all conditions in detail. Here are the internal factors of our SWOT analysis. These are the strengths and weaknesses of research. The first one strength is that author wanted to examine the different geometries of spectrophotometers, that either these geometries are affecting the measured color coordinate values or not. And the second one plus point was that the author involved different type of fabric textures manufactured of same color, because in our daily life we often observe that two person wearing the same color fabric but with different textures, the fabric is showing a different shade. While the third one plus point was that author used statistical analysis to observe the effect of input factors on the output obtained. It happens in most of our laboratory experiments that we predetermine that this factor will affect the output, and in our conclusion we write blindly that factor that it is affecting our output, but sometime in the statistical analysis that factor hadn't any effect on output. So statistical analysis involving was a plus point. Then the fourth one strength was the visual assessment comparison with the measured spectrophotometric values, as author wanted to know that which one is the more precise and accurate method for the color measurement, and it was ultimately proved that spectrophotometer is a more accurate device for the color measurement rather than the visual assessment. And the fifth one plus point was that author used a wide range of colors to examine the effect of texture on colors and effect of textures on the changing spectrophotometer geometries. So these all 5 points were the strengths of our research paper. Then the weaknesses of SWOT analysis are the keeping yarn count constant during the all samples manufacturing, because yarn count has directly effect on the fabric properties, but the author in the research kept a single yarn count of 160 denier, and he said that the texture hadn't any effect on the spectrophotometer geometries changes, while if he will use the different type of counts of fabrics, then it might be possible that texture will affect the spectrophotometer geometry. So it is the weakness of the research that the author doesn't use the different yarn counts, while the second one weakness was that the author doesn't describe the any of the laboratory condition such as temperature and humidity, because humidity level and temperature adversely affect the moisture content in the fabric, and the moisture content affect the reflection of light, and color is the ultimately result of light reflection, so color can be affected. While the third one weakness was that in the result portion the values of chroma and hue was not described in any of the point. Simply L, A and B values were described, which were not enough for the comparison between the two spectrophotometers results. While the fourth one weakness was that author included the specular component of light in diffuse by 8 geometry, while he excluded the specular component of light in the 45 by 0 geometry. So these conditions of a specular component were not same in the both spectrophotometer, and it might be possible that specular component of light had affected the result, and true comparison of spectrophotometer geometries cannot be obtained. And the fifth one weakness was that the author used only single standard illuminant of day 65. He doesn't change any of other standard illuminant in his research, and the all result were based on the same illuminant, so it might be possible that the illumination change can affect the results. Here are the external factors of SWOT analysis. These are the opportunities and threats related to the research. The opportunities which can be availed in future from the current research are the following. The first one is that the research opened a gateway of using spectrophotometers of different geometries for color measurements and analyzing their effect. That in future researchers may use the more than two or three geometries of spectrophotometers in order to analyze that which one L, A and B measured values are more accurate for colors, and ultimately they will find that this one geometry is more accurate for color measurement. The second one opportunity is that the industrialists can manufacture the fabrics with the different LA, A and B values while using the same color yarn. The industrialists can create these effect of different LA and B values by varying the fabric textures, as the author varied the fabric texture in the research, and ultimately the LA and B values of the color were varied. The third one opportunity can be created is that the statistical analysis software use will be promoted in order to check the exactly which one of the input factor is affecting the output. Um, the research will ultimately open a gateway that every researcher will analyze his results of experiment in a statistical digital softwares, and the software will ultimately provide a more accurate results rather than the manual assessment of results that this factor is relating to the output. While threats involved of the current research are the neglection of ion count in the research can mislead the further researchers that textures effect remain constant for all geometries, and there is a possibility that by varying the ion count the effect would be different. The same thing was discussed in the weakness of the research, that the author kept the ion count constant, and the results obtained can mislead the researchers in future that textures doesn't affect the spectrophotometer geometries and these remain constant. While if we will use the different type of ion counts and textures, it might be possible that the texture will affect the spectrophotometer geometry. While the second one threat which is caused is the uh, including specular component of light in d by 8 degree geometry while excluding it in the 45 by 0 geometry, So the all obtained results are not purely related to the spectrophotometer geometries. These also can be affected to the specular components of lights included or excluded. So these results can mislead to the researchers in future, which will work more on these topics. So this was the overall SWOT analysis of our selected research paper, and we discussed completely the strengths, weakness, and opportunities and threats related to the research. Now we are heading towards the conclusion of our presentation, which is related to the summary and SWOT analysis of a research paper. The first point is the research analysis showed that spectrophotometer is more precise and accurate device for color measurement rather than visual assessment of colors, and the same thing was experienced in the results that the color coordinate values and delta E values obtained from the spectrophotometer were more accurate than the visual assessed values from the common grayscale, because the visual assessment can also vary from a person to person or on the condition of eyes. And the second point is that different spectrophotometer geometries show different color LA and B coordinate values due to angle difference between the illumination source and observation points, and ultimately when the angle between the illumination source and the observation point is changed, we will experience a different type of color, and the same thing was experienced in the research. There are many plus points which can be achieved in the light of this research, but some limitations will also be experienced due to weak points of research, as in SWOT analysis. The complete SWOT analysis has been completed and showed that there are some plus points and some negative points of the research which can be kept in mind for the further researches related to this topic. Here is the reference citation of the research article, whose summary and the SWOT analysis has been performed in the presentation, and all the provided information can be calibrated with the article. Thank you. Thank you very much. Allah Hafiz.